Okay, so I thought I'd put up another combo circuit for you, something just something new to work on, some new numbers to solve. So you have all the values right here, 120 volts, R1 is good for 0.15 kilo ohms, R2 0.11 kilo ohms, R3 is good for 300, and R4 1.43 smackaroos. So just pause the video as you go, and I'll just keep inserting values one at a time. So just one more time to have the conversation before we wrap this all up here. So pause the video, and I'll be back in 3, 2, 1. So now it's important with these to really nail RT. If you don't get RT right off the bat, I would say you spend a majority of your time making sure that you have the concept of solving for RT down, because everything in here is going to be incorrect associated to RT. So in this case, assuming I solved it right, or correctly, 253.42 ohms, IT gives us 0.4735, and PT 56.82 watts. So keep going. I'll pause the video, and I'll input some more values. In 3, 2, 1. So just to show here that R1, you're going to drop some voltage across R1. R1 is going to see the entire current in the circuit, so we can just take the 0.4735 amps, which is your IT, multiply it by your 150 ohms. And it's important here, the 0.15, when I give kilo ohms here, or a decimal, 0.11 kilo ohms. Again, where I get hiccups from students is the conversion. I'll get this number kind of all wacky. It won't be, I'll get 0.150 multiplied by the decimal, and it just doesn't work out very well. So, or at all, really. So, always important to convert into just straight ohms when you're dealing. So, we have 71.02 volts is what's going to be dropped across this resistor, which means the rest of this, so we'll take the 120 volts minus, so the 120 minus what got dropped here, and we're left with 48.98, and that's what the rest of this circuit is going to see. So you're going to have 48.98 volts down R2, and R3 and 4 are going to see that voltage. So pause the video and see if you can fill out the rest. In 3, 2, 1. So the rest of our voltages here, or our, what we all solve for, the current in R1 is sort of just the reverse of what this is here. So the current R1, 71.02, 150 ohms, we're just going backwards, gives us 4735. And then we can keep going with our current in R2. That is going to see the 48.98 divided by your 110 ohms, gives us 4452. R3 and R4 are going to see this voltage, but the current, they're going to have the same current because these two resistors add up. These two are in series. So we have, they're going to have the same current. And the power is just going to be adding up the individual drops from each component, so from each resistor. So we dropped 71 volts across R1. We had 0.47 amps across R1. R2 dropped the entire voltage across there. Ended up with this is the current in R2 right here. The voltage drop across R3. So now the voltage drop across R3 here. Notice R3 and R4 have the same current that we're using because they're in series, so they're seeing the same current. So the current times the resistor, and the current times the resistor. And again, what you're looking for is these relationships where this is 1430 ohms, this is 300. It stands to reason you're going to drop a lot more voltage across the one resistor. And you just add them all up and pause the video. And we're back. And what we have is, I just sort of highlighted a couple of the things to look out for here. The values that we're using, 300, the 0.2, 0.02. And these should now, what you want to do is these should sum up to roughly 48.98, and this is where you want to double check your work. So this should sum up to 48.98. These two here, you don't add these two together because they're seeing the same current, but these two should add up to your source current, and then all these should add up to roughly your total watts. So, just to finish it off, significant figures. How many significant figures for the current in R2? So how many significant figures here? And scientific notation for the current in R3. What is the scientific notation of this value here? And I'll let you pause the video. And we're back. So we have 4 significant figures for R2. And we have 2.83 times 10 to the negative 2 for the current in R3. And that wraps it up for today. Sorry, one more thing. R3 and R4, just to sort of sum this up here, these get added together. So this is how we sort of break it down. R3 and R4 to start this off, so we add them together. That comes to 1730 ohms. That's R3 and R4. And then we parallel these two, and we add them together, and we end up with 103.42 ohms for the two resistors. So that's R2, 3, and 4. And now we combine these together, and that's what gives us our RT. So I just wanted to finish that off. Thank you.